Active Technologies AWGs can be configured as powerful digital pattern generators. These features helps you to emulate serial or parallel bus transition or custom digital interfaces for mixed signal test debugging and characterization. Below the two analog waveforms, we have 8 digital signals that can be grouped in a bus configuration by pressing the Digital Groups button. On the Digital Grouping window, click on the checkboxes to select multiple digital lines and hit Group Selected to make a bus. Now, we can change the name of the bus and of the single signals. Press the left mouse button like changing the name of a folder and rename the bus to Address, the second bus to Data, the single lines to Write, and CLK, that stands for clock. You can expand the bus, and on the second column you can notice that it displays the association between the logical name of the digital line and the digital output channel. On the digital graph, you can click on the tree node to expand or collapse the bus, and we can use the digital waveform tools to make changes on the digital graph. Let's examine all these tools one by one. The counter editor lets you to program a digital count value to a single signal or to a bus. You can specify a start and stop value, the increment, and decide when the transition occurs. It can be set in time or every 1, 2, 3 or n samples. As you can see, on the address bus has been programmed a counter from 0 to F. The value tool allows you to set a digital value over the selected digital bus or single line. You can change the radix of the value, from binary to decimal, hexadecimal and octal. We select decimal and type 2. Then we make another selection, press the value tool and type 3 as value. The 0 and 1 buttons allow you to set the signal or bus value to 0 or 1. Click on the clock icon to open the clock settings window. Here, you can easily set a clock waveform, changing the period, the offset and the duty cycle. Let's make an example. We can change the period to 400 nanoseconds, press OK button, and the clock waveform will appear on the clock line. Finally, the invert button inverts the value of the digital signals, and the R button inserts a random number or a set of random numbers in the selected area. To program a set of random number, select a waveform area, then press the R button and specify after how many samples you want to change your number. So we type 1000 samples. Press OK, and your set will be ready. The fine selection tools are also available on the digital waveforms. You can use selection start and selection stop controls to make accurate selection on one or more waveforms. You can also copy and paste the digital values from one signal or bus to another. To do that, select the digital waveform area, press Copy, select a destination area and press Paste. Once we have created our digital waveforms, we need to transfer them to the waveform generator. The procedure is the same we have applied for analog waveform, so click on the Save Selected Waveform, type the digital waveform name, its description, and hit the button Save in the waveform list. As we return in the True-Arb application, you can see that in the waveform list are present the digital lines we've just edited. Digital lines are disabled in the instrument. To enable them, let's go to the Channel Settings page and select 8 digital channels. After that, we can choose the digital waveform test in the second entry of the sequencer and we can turn on the digital channels. We can press the Run button to start the waveform generation. The data editor can be used to edit analog and digital signals in a tabular format. The samples are displayed numerically in columns and the values can be edited point by point like in a spreadsheet editor. If you click on the header of the analog waveform column, you can open the analog waveform structure and see the segment and the components. The first column of the table is the samples column that shows a progressive index of waveform samples, while the second column with the header name time displays the progressive absolute time of each sample. Also for the digital lines, clicking on the header of the column, you can open the bus and edit the cell values. On the data editor, you can perform all the operations that we have seen on the graphical editor. All the changes that you make on the data table are reflected in the waveform graph and vice versa. Using the data editor is very convenient when you need to insert, for example, a spike on a waveform, or when you need to modify point by point an existing waveform. I'm going now to insert a spike on the analog waveform 1. There is another way to modify the waveforms point by point. Select the analog waveform 2, then press the button Edit Waveform and change the values inside the cells. The data import functions allow importing waveform data created outside the waveform editor software. You can import data to create a new waveform or to replace existing waveform data. Let's make an example. Select the analog waveform 2 as destination and press the import button. The import form opens and we choose the file to import from our desktop. Multiple file formats are supported, and in particular they are tab-separated text files, comma-separated values files, TRC files that are Teledyne-Lecroy digital oscilloscope files, other formats that are from Tektronix oscilloscopes, and also MATLAB files. On this window are available many options to import the file. The sample rate specifies the sampling rate of the samples that will be imported. After that, you can decide how many lines to remove in the header and what kind of decimal separated point or comma you are using in your file. The sampling rate of the instrument can be different from the one set on the file. Using this drop-down list, you can choose the interpolation method that the software will go to apply. It can happen that the file we need to import has more points than the current waveform. With the memory overflow options, you can choose to cut off the last points or the first points. On the contrary, if the file has less points than the waveform, we can decide to set the last points to 0 or keep the last waveform sample. Hit OK to import the file. The steps are very similar also for the digital waveforms. Select the digital waveform, press the import button, choose the file, and the digital data will be imported in the digital waveform graph. If we open the digital waveform data with a text editor like Notepad++, we can notice that the first row contains a header that represents the number of the digital channels associated to the logical name. Each column of this comma-separated value file contains the data of the single digital lines. I'm going to open now the analog waveform file. The first two rows contains the sample rate and the total number of samples, while the other rows contain the analog waveform values in double precision format. We've seen before the import of a text file with a single column. If the selected file has more than one column, the following cases can happen. If the text file contains a mixed waveform with header, the first column will be interpreted as analog data, while the other columns will be decoded as the digital lines. Note that the digital lines that will be imported depend on the number of the lines available in the current project. With a text file made of 2 columns without header, the first column will be imported as an analog waveform, while the second column will be imported as the marker one. If the text file has 3 columns without header, the first column will be imported as an analog waveform, while the second column will be imported as a digital line 0 or marker 1. The third column will be ignored. When the text file has more than 3 columns without header, the first column will be imported as an analog data. The other columns will be imported as digital lines. You can easily import scope waveforms exporting waveform data in a text format, or if you have a Teledan-Lecroy oscilloscope, saving your waveform in TRC format. After that, you open the waveform editor, press the import button and load the TRC file. In this case, it is called C1 trace. Press open, and then we can select how many lines to remove, in this case 2, and select the interpolation, because the sample rate of the file is different from the one you set on the instrument. Press OK, and the waveform will be imported in the waveform editor.